Okay, hi everyone. This is the first energy economics lecture after break. Um, so let's do a little housekeeping before we get started on the lecture. I hope everyone's doing well, not sick, or if you are sick, it's not super serious. Um, so let's hope this goes well. This is my first go at doing online lectures, and as I said before before the break, please let me know if you have trouble with any of the stuff that I'm doing. If you can't access the lectures or anything after I post them, um, I will be happy to assist in any way I can. So a little housekeeping. I was originally thinking we would have the midterm right after break, or at least we'd have a homework right after break. Turns out everything got all screwed up. So I'm just going to have the midterm due April 3rd. I will post it on probably a couple days beforehand. It's going to be a take-home midterm, and basically it's going to be just a homework assignment with a little bit of extra involved, not just a regular homework assignment. At least it'll be worth more, but it will be comprehensive for everything that we've studied so far in the class. The nice thing for you is that you get to use whatever resources you want. This is not going to be a obviously I can't proctor your midterm right now. We could set that up, but it sounds like a lot of work at the moment, and there's already plenty of things that are making it hard. So let's just do a take-home midterm, due April 3rd. I will post it next week. And you're welcome to use whatever resources you want for that, including working with each other. Obviously, you're not supposed to get together, so you could meet online or whatever. Another thing I want to note is that it turns out I won't be doing live lectures. I will be recording these lectures beforehand and then posting them, and I will send you information on Canvas on how to access the lectures. The reason for that is because it's just going to be really difficult for me to keep this schedule. We have 2 kids that are not in school anymore for the remainder of the semester, and so I'm teaching kindergarten, swapping days with my wife teaching kindergarten, and also preparing to teach these courses. So my wife also has to work, so luckily we have our jobs. We still have to work, but it means that doing live lectures is not going to happen. So I will post the lectures, and it also means that you can watch them in batches if you want. Let's see. I will be holding live office hours, though. That's still going to happen. I'll do that Monday and Wednesday, same times as before. Monday and Wednesday, 2 to 3:30. I'll do that via discussion on Canvas, and I will send you information on how to do that, how to access those, or how to log into that. And of course, feel free to email me, or I guess email is the only way you can really get in touch with me at this point. But we can set up times to talk if those discussion times aren't going to work for you. I'm flexible, and I want to make this as seamless as possible for all of you. So I want to figure out how to keep you engaged and keep you learning. And so that's going to take effort on both of our parts. So please come to the office hours via discussion, and I'll show you how to do that later. And then also, please let me know what you need, how I can help. And then also, to keep you engaged in the course, I'm going to post discussion questions that you will need to respond to for credit. So that's something that's changing in terms of how this course is graded. I haven't done this before, but we are adding I think some of you have probably seen this in your other courses where I'll post a discussion question and you have to respond to it online, and you'll get a little bit of credit for that, just to keep us all sort of coming to class, so to speak, and to keep us all engaged in what we're talking about. The first discussion question, I think, will be, how should we think about trading? Because we still have to trade on stock track. How should we think about trading in a market like this? The answer, I don't know. We all have to think about that. I don't think anybody really knows. Hopefully the stock market exists in several months. I'm sure it will, but it seems like things are changing. So we have to think about what it means to be trading in a market like this. Okay, so let's get started with today's lecture. You should be able to see my slides. We're going to be talking about fracking. We're going to be talking about fracking and pipelines in North American gas markets. So this is a new topic. We finished up oil, sort of. I mean, we're still trading oil futures, but we finished up oil the slides for oil last the weeks before spring break. And so now I want to cover pipelines and fracking for a little bit. So what is fracking? What are we talking about? All right, so the agenda for today: introduction to natural gas, what is hydraulic fracturing or fracking, and pipelines and market integration. So natural gas, some consider it the most environmentally friendly fossil fuel. It's composed of primarily methane with small amounts of heavier hydrocarbons like ethane, propane, or butane. These are also contained, ethane and propane, butane, these are also contained in oil. So I've mentioned before that anytime you drill, you get both natural gas and oil. They go together. You can't get one without the other. So when we were talking about oil refineries, when they take in oil, they heat it up, some of the oil separates naturally when it's heated. The lighter hydrocarbons rise to the top, and some of those lighter hydrocarbons are ethane, propane, butane, and even methane. So sometimes when you heat up, or always when you heat up oil, you're getting some natural gas out of it. So that's the lightest stuff. And so refineries are also processing this stuff, but we can get it directly from wells, and that's what fracking is doing, or just drilling any sort of well. You can harvest or extract natural gas at the same time you're extracting oil. There's less carbon dioxide per kilowatt hour of energy produced than any other fossil fuel with natural gas. So it's a cleaner. It's the cleanest of the fossil fuels in terms of carbon dioxide production when we burn it for electricity production. Let me be clear about that. It's not completely. We're not getting off scot-free when we burn natural gas. I'll tell you why in a moment. There's significantly less nitrogen oxides than oil or coal, and virtually no sulfur dioxide or particulate matter when it's burned to produce electricity. So when we went to Rawhide, we saw that they had natural gas burners outside of their coal plants, and that's what we're talking about here. What are the emissions from burning natural gas to produce electricity? Less than coal, virtually no sulfur dioxide or particulate matter. There are questions about the environmental quality of natural gas when considering extraction. So what we were talking about in the previous 3 bullet points was the environmental quality from burning to produce electricity. When we're talking about the environmental quality of extraction, we have to be a little more cautious in describing how clean it is. Extraction releases a lot of methane, another way to say that is extraction releases a lot of natural gas, because natural gas is methane. So when you drill a well, uh, you don't immediately tap it and there's leaks. And so some of that natural gas is going to get into the atmosphere, and methane is much worse for the atmosphere than carbon dioxide. I can't remember exactly how much worse it is, but I know it's much worse. The good thing about methane, though, relative to carbon dioxide, is that it's shorter lived. Carbon dioxide lives in the atmosphere for a long time. Methane lives in the atmosphere for a short amount of time. So it's not a panacea. It's not a solve. It's not a fix for the climate change problem. The other problem, so pipelines, natural gas, we'll get to this, but natural gas is transported around the United States via pipelines. Pipelines are leaking much more than we thought. So in the past, we kind of thought pipelines were great. Once you get the natural gas into the pipelines, we're good to go. It's not really dirty until you burn it. It turns out that pipelines are leaking quite a bit. And so there's current research here at CSU at the Energy Institute down on College, or up north on College. Current research looking at the quantity of natural gas that's leaked into the atmosphere just from transportation in pipelines. It's quite a bit. So we have to be concerned about that. And for these reasons, many countries have actually banned fracking. You can find out which countries those are if you, there's a nice video that I linked to in a little bit here. So what do we use natural gas for? Where do we use it? Electricity generation, and that's about 36% of natural gas consumption in the US in 2016. So that's the combined cycle, or not necessarily combined cycle, but we have combined cycle is one type of natural gas powered plant. Rawhide had, I think they had one or two of these, and then they have some other non-combined cycle ones. The combined cycle ones can ramp up faster or slow. They ramp up slower, but they're more efficient than the non-combined cycle. So the non-combined cycle, it's less efficient at converting heat into electricity. So there's more heat loss, but they can ramp up more quickly. And we also use it for heating in our homes, heating in commercial buildings. We use it for water heating. We use it for cooking. So it's a fairly prevalent resource. You have a natural gas pipe coming into your rental home right now that's powering your water heater probably. Most of you probably also have natural gas heating in your homes. It's also used for industrial process heating, like steel manufacturing, aluminum manufacturing, or glass manufacturing. Anytime an industrial process needs heat, a lot of it's probably coming from natural gas. And then feedstocks for chemical manufacturing. So example would be fertilizers. There are distinctive seasonal patterns to natural gas use for residential and electricity generation. We can see that in the graph below. Unfortunately, it's cut off on the bottom. Okay, so the left-hand side of that graph, the bottom, hopefully you can see my mouse here. And that's 2010 month one, so that's January 2010. Here's 2011 month one, January 2011, 2012 January, 2013 January. So we can see that for the electric power sector, we have peaks in the summers. So this is the summer period. Why do we have peaks in the summer for the electric power sector? Well, the peak demand for electricity is during the summer, when we need electricity to power AC, air conditioning. So we need more electricity during that period when it's hot to cool our homes. Why do we see the opposite pattern in the residential, the dark gray? So the peak demand for natural gas for the residential is during the winter. Same reason we see the peak in the summer for electric power, but it's the same but opposite reason. The residential peak comes in the winter because that's when it's coldest and we need to heat our homes. So the orange peak, the orange dotted line peak, and the gray peak, The gray solid line peak are both for heating and cooling of residential and commercial buildings. What about, so commercial, we see that as the peak in the summer as well. There's less demand for natural gas from commercial than there is residential. So we're heating less commercial than we are residential. And industrial has small peaks during the summer as well. Why might we see small peaks in the summer for industrial? Well, one possibility is the business cycle. So typically we see demand for manufactured goods rising in the summer periods. So perhaps that's why we have these little peaks in the industrial natural gas demand during actually that's wrong. Those are during the winter. We have declines in industrial demand during the summer. I'm not sure why we see that. The opposite trend there. All right. Where is the natural gas in the United States? Where is the shale oil and gas? Where are the shale oil and gas fields in the U.S.? Here are the lower 48 states. Shale plays. Okay, so the dark orange are the current shale plays. This is where we're actually drilling for natural gas right now. We also have current plays that are outlined in blue. So there's some east of us in Fort Collins. Actually, there's quite a bit east of us in Fort Collins. We have some suspected or prospective plays in light purple. So these are the areas where we think that there's natural gas, but we're not quite sure. So there's a lot of natural gas in the U.S., a lot of shale that we can extract from. We saw this during the oil section of the class. We saw that the fracking boom led to rapid increases in U.S. natural gas production. Actually, it also led to rapid increases in U.S. oil production, which pushed down domestic prices for both oil and natural gas. This graph here shows natural gas production in the U.S., Canada, and Mexico in billions of cubic feet per day. So you can see right around the mid 2000s, like 2005, we start seeing a dramatic increase in U.S. natural gas production. That's when fracking is really coming online. I think it was around 2006 that it really started to take hold. So what is fracking? We still haven't defined fracking, but let's do that. Fracking refers to hydraulic fracturing, which is the forcing open of fissures in the subterranean rocks by introducing liquid at high pressure, especially to extract oil and gas. That's the definition. What is it actually doing? So we're drilling down, just like we would a regular well. We can drill down, and we can also drill at an angle. So let's assume for the moment we're drilling down and straight down. We could do that for miles if we want to. That's the traditional oil wells. We drill straight down, maybe at an angle, but we'll think about drilling straight down for quite a ways. Fracking is then, okay, not just drilling straight down, but drilling then, once you go down, you take a 90-degree angle and start drilling sideways. And that's called horizontal drilling. The reason you might do this is you might be able to go under rock, or go under, initially you might be able to go under things that are hard to drill through. Like if you have a band of granite or something, you might want to go under that if possible. But another reason is you can access pockets of oil and gas that are captured in what's called shale. Shale is a type of rock, and so you want to break open that shale and allow the oil and gas to be released through the cracks or the fissures that you produce by breaking open the rocks. And how do you break open the rocks? Well, you pump down water and other chemicals at high pressure such high pressure that you actually fracture the rocks, which allows the natural gas and oil to escape. So fracking is basically you drill down, then you drill sideways, and once you've drilled these holes, you cap them so you can put water and other chemicals down them at very high pressure. I think each well consumes 30 million gallons of water or something like that. So you're pumping a lot of water down the wells. You're doing it at really such high pressure that you're actually cracking rocks. And when you crack the rocks, you put some sand in or these little beads in that keep the rocks open or keep the rocks from collapsing back in on themselves. And that allows the oil and gas to come back up. And you have to, of course, do something with the water that you've used that's now contaminated with oil and also the chemicals that you've used. So one of the other environmentally damaging things of fracking is dealing with the wastewater, 30 million gallons of wastewater. It turns out that horizontal drilling and hydraulic fracturing techniques have been around for decades, since I believe around the 40s, but they weren't economically viable for a long time. So they knew how to do this. They just didn't know how to do it cheaply. And also oil and gas prices were low enough that it didn't make sense for them to do it. How far can we drill sideways? The longest drill, when I looked this up a minute ago, was the longest horizontal drill was 7 miles. So if you can imagine, you can drill down a mile and then go 7 miles sideways. That's amazing. You can go a long way. So what does this sideways or horizontal drilling mean for local fracking bans? That's a huge question that Colorado has been grappling with. On one of our recent ballots, we could vote on whether or not we wanted to ban fracking near and around residential areas, for example. Or what do we want the boundary or the limit, the distance between residential areas and fracking sites to be? That was one of our ballot measures. The arguments in favor would be, well, fracking is environmentally damaging. It releases pollutants into the air. One of the projects that several people in the department are working on is how the pollution from fracking impacts school-age children's test-taking ability. So we know that pollution affects cognitive ability, and when you drill a well near a school, does that affect the students' ability to take tests or learn, essentially? Are we polluting our schools, basically? So one of the benefits of limiting fracking is we're going to cut down on pollution near and around residential areas or cities. We would also cut down on noise and distractions. Of course, there's also counter arguments to this. One counter argument might be that there's a lot of jobs in oil and gas, especially in Colorado and Wyoming. And if we put a ban on fracking in certain parts of the state, then we are potentially taking jobs away from people. Some people have also argued that putting a ban on fracking is going to reduce the amount of oil and gas that's produced, causing increases in the prices of oil and gas. Well, we know from the oil section of class that part's not true. Perhaps it's true for natural gas, as we will see, but I'm skeptical for one state or one region's production. The other thing is horizontal drilling. If we can drill up to 7 miles sideways, does it really make a difference if we set boundaries around residential areas of, I can't remember I should have looked this up, but I can't remember what the proposed boundaries were, but they weren't that far. Let's say they were half a mile from a residential area. Suppose there's gas and oil a mile underneath a residential area. If your boundary is half a mile or even a mile away, you can still access that oil and gas. If you drill a well a mile away and then go horizontally underneath it, under the ground towards the residential area to access that oil and gas. So you can still extract it. And there's some people at the School of Mines down in Golden that have done this analysis. They've used remote sensing and GIS to figure out what the proposed fracking limitations would have done to the oil and gas industry. How much of Colorado would, in particular Weld County, because that's where a lot of it is, how much of the area would have been lost had the ballot measure passed? And it turns out that increasing the boundaries around residential areas from, I can't remember what it was, but it turns out they would have lost something like 1% of the area that they could have accessed. And that's all due to their ability to drill horizontally. And I think they only used in that study a distance of 3 miles. So even with horizontal drilling of 3 miles, when the maximum is 7 miles, they could access nearly all of what they could have accessed prior to this ballot measure. So limiting where you can put a well really, with boundaries around residential areas of half a mile to a mile, really didn't seem to have much of an effect on the amount of oil and gas that could be extracted in Colorado. So we've had this technology since the 1940s, but recent innovations decrease the cost of using the techniques to extract oil and gas. I suggest you, which means that we now have fracking as part of our supply chain. So I encourage you to click on the TED video at the bottom of this slide to see what fracking actually is. What about the prices for natural gas? So we have the WTI, the West Texas Intermediate, which is the benchmark U.S. crude oil price. We have the Brent crude oil price, which is the benchmark European crude oil price. We have the Arab Light crude oil, which is the Middle Eastern benchmark. For natural gas in the United States, we have Henry Hub. This is the benchmark crude natural gas price in the U.S. You can trade natural gas futures on NYMEX or the CME, just like you've been trading oil futures. Oil prices are typically quoted in dollars per barrel. Natural gas prices are quoted in dollars per million BTU, which is roughly 293 kilowatt hours. Let's take a look at what prices have been doing in the natural gas market. So here are the Henry Hub natural gas futures relative to the crude oil markets. Let's look at the crude oil futures. Let's look at those. Those took a sharp decline on May 9th. What had happened on May 9th? Natural gas did not respond the same way. Interesting. I wonder why that is. We might have that as a discussion question later on. Crude oil futures continue to decline. Natural gas prices are in decline, but they did not take a sharp decline on March 9th. Interesting. Okay, back to our slides. That would be an interesting question to analyze for research. Are the markets integrated like the oil markets are? Unlike oil, large price variation shows that the world natural gas market is not fully integrated. So here's Japan's natural gas price, Germany's natural gas price, the UK's and the US natural gas price. They are not the same. Oil prices during over time. This is the WTI and the Brent. You can see for the most part they are the same. We saw that they diverged when the fracking boom hit, and that was largely because there was an increase in the domestic supply of oil, but there was an oil export ban, so there was a glut of oil in the US, which could not be exported to the world oil market and sold at world prices. So the US, for a short period of time, had lower oil prices, the WTI, than the world oil prices, the Brent. Natural gas prices are not globally integrated. Why are natural gas prices not integrated? Well, natural gas is more expensive to transport than oil. It's also more expensive to store. Oil just sits there. It doesn't float away. You can put oil, you can put it in a bathtub and let it sit there, maybe put a piece of plastic over it, and it's not going anywhere for millions of years. Natural gas will leak out. It wants to get into the atmosphere. It takes a lot more to store it, which means it also takes a lot more to transport it. You have to have leak-proof pipelines. You have to have leak-proof storage facilities. Not that you want oil leaking, but the leaks are a little more hard to contain. You're storing a gas versus a liquid. There's two ways to transport it. We can transport it via natural gas pipelines. We can transport it, or we can condense it into liquid. So natural gas pipelines, the ones we typically think of, and the ones I'll show you on the next slide, they are transporting gas, not a liquid. So we can also condense it to a liquid by lowering the temperature to negative 260 degrees Fahrenheit. That's when natural gas turns into a liquid, or methane turns into a liquid. And then once it's turned into a liquid, we can transport it into specialized ships, and this is called liquefied natural gas. You can imagine it's a lot of money to build a plant that can cool natural gas to negative 260 degrees, or it costs a lot of money to build that plant. And it also costs a lot of money to build facilities that can store something that cold, or at least if it's not that cold, it has to be at high pressure. We have to, it's expensive to do that. So there's very little, the US has very limited participation in the world natural gas market. We have very few liquefied natural gas import terminals, and until recently we had no liquefied natural gas export terminals. So in other words, we are, or we're natural gas independent. So we've talked about, is it relevant for the US to think about oil independence? Well, the answer to that question was no, because the oil market is really globally integrated. The natural gas market is not, largely because of transportation costs. And so we are essentially natural gas independent. Here's the US natural gas pipeline network. The blue are the interstate pipelines, or the pipelines that go across state lines. The red are the intrastate pipelines within states. One thing I thought that was interesting here is the amount of pipelines going into the Gulf Coast around Texas and Louisiana. So those, we're extracting natural gas from offshore drilling, and we're piping it in. And you can see the hubs, just like the oil, down on the Gulf. And then we also have the hub in Louisiana. That was the Henry Hub. We're going to have some hubs up by and around New York. All right. Should the U.S. participate in the world natural gas market? Should we start becoming natural gas dependent, or perhaps maybe supplying natural gas to the world market? An increase in the supply of natural gas in the U.S. due to the fracking boom has pushed down domestic prices of natural gas compared to the prices in Europe and Asia. Okay, so the price in the US is lower than it is in Europe and Asia. What does that mean if you're a natural gas producer? That means that you're selling natural gas into a market with lower prices than you could sell it elsewhere. So if you are a producer, you want to sell your natural gas at, of course, the highest price you can sell it for. So you're going to want to sell your natural gas into the European and Asian natural gas markets. That creates an arbitrage opportunity. Um, so uh, the U.S. natural gas price was about 1/3 the price in other countries. So um, if you're a producer here, you want to sell it over elsewhere. So many firms, in response to this, many firms sought approval to build liquefied natural gas export facilities to take advantage of this opportunity. So if we're going to transport it over to Europe and Asia, we need we need to do this. We need to liquefy it first. We can't really build. It's not super feasible to build a pipeline to transport natural gas in its gas form from the United States to Europe. Better to do it by liquefying it and putting it on ships and then transporting it just like we do oil. I would not want to be on that ship. So firms sought approval to do this, to build liquefied natural gas export facilities in the United States. And suppose the government approved of the construction of these terminals, who would be better off? Who would be worse off? So the question is, would the producers be better off? Well, yes. They're going to be selling their natural gas at higher prices on the global market than they would in the US. So they're going to receive higher prices, although they're going to be incurring higher marginal costs because they're actually having to liquefy their natural gas, which is going to cost more. So it's not a windfall profit. It's not as great as you might think. So it really does depend on what the price of natural gas is doing in Europe and Asia. Even though prices were 3 times as high in Europe and Asia, we have to get it there, which is going to cost us a lot of money. Who's going to be worse off? Well, we'll see in a moment that U.S. consumers are going to be worse off. They're going to be paying higher prices. The natural gas price in the U.S. is going to go up if they do this. Is the government going to be happy? Is the government going to benefit? Depends on the policies that the government implements. It depends on how they tax exports of natural gas. So if they tax the exports, yeah, they're going to be happy. Why hasn't this happened? Well, unfortunately, the liquefied natural gas exports no longer look profitable. The prices collapsed in 2016. This figure at the bottom shows this. This is the price of liquefied U.S. natural gas exports. And you can see in 2016 it collapsed. Why did it collapse? Natural gas prices in Europe and Asia are still benchmarked to oil prices. So when oil prices decline, this leads to large drops in the natural gas prices in other countries. There are 4 liquefied natural gas terminals currently under construction in the US, and several may not be completed because of this. Well, probably the natural gas prices are going to go up in the future, so they will be completed at some point, probably. So long as we continue to use natural gas. I don't see natural gas leaving the world market anytime soon, so we will probably complete those at some point, depending on how the current crisis shapes out too. Shapes out. What about Mexico? Okay, so we were talking about Europe and Asia. There's also a large market just south of us. Mexico, natural gas consumption in Mexico is rapidly increasing, with imports also becoming increasingly important. I actually, a little digression, you can look up the price of oil was so high that it was putting the cartels in Mexico. They were switching from selling cocaine and heroin to selling oil. They were stealing oil from Mexican companies and uh, and then selling it. Uh, I'm not sure if they were stealing refineries as well, but um, some cartels in Mexico were actually changing their business strategy from cocaine and heroin to oil. And you can look up a Vice documentary on YouTube about that. That's probably changed since the collapse of the oil price in the last month or so. So I wonder how quickly the cartels can respond, because when the economy collapses, I'm sure heroin and cocaine consumption will increase. Um, but that was a digression. Let's get back to natural gas. Natural gas consumption in Mexico is rapidly increasing, with imports increasingly important. So we can see in this graph that's on this slide here, natural gas production in Mexico was met by, or natural gas consumption was met by natural gas production in Mexico up until about 2000, at which point natural gas consumption outpaced natural gas production. So that gap needs to be met by something, and that's going to be met by U.S. imports. So there's an alternative opportunity for exporting natural gas from the U.S., and that's by pipeline to Mexico. To export natural gas by pipeline to Mexico, we don't need to liquefy it, so it's cheaper. We just need to extend our current pipeline system down to Mexico. So there's an opportunity for both countries to benefit from the construction of natural gas pipelines between them. The government of Mexico is currently undertaking an ambitious project to build out natural gas infrastructure. The Mexico pipeline imports grew from 20.6 billion cubic meters in 2014 to 29.9 billion cubic meters in 2015. The Mexico pipeline, so the imports are growing substantially. The Mexico pipeline imports will continue to grow as new pipelines are completed. So the U.S. is considering building new pipelines. So let's look at some stylized examples of how the markets would be integrated. Bear with me for a second. I'm working on getting my going to get a whiteboard up on your screen here in 1 second. I had it up, but it went away. Here we go. Okay. What's our question? Our question was, this should not be on here. Let's move that over. Okay. suppose that we have supply and demand in the USA and Mexico. Our supply and demand are given supply and demand for natural gas. Let's go with supply or the demand, the USA. Still figuring this out. Demand USA equals 40 minus 2P USA. And the quantity supplied, again, quantity supplied USA equals 8P. Okay. And we have a quantity supplied and a quantity demanded in Mexico as well. Quantity demanded in Mexico is going to be 6 minus 1/2 P Mexico. And quantity supplied I apologize. I am still working this out. All right. Quantity supplied Mexico is going to be 2. Okay. Suppose there's no pipelines between the US and Mexico. Find the price and the quantity in each country. All right, this is fairly easy. We know how to do this. We just find the equilibrium in each country. So let's set the prices and quantities equal to one another. Let's draw a little graph here. So here's the quantity in the US, price in the US. Demand intersects at 40. Over here, it's going to intersect at 20. We can draw, there's our demand curve. We'll have our supply curve. So we know that this is going to be 20. Let's give a couple. Okay, there's some marks, tally marks. No, that's about 32. Let's find the equilibrium in the United States. Okay, equilibrium is given by setting supply equal to demand. So let's do that. 40 minus 2P equals 8P. So then 40 is equal to 10P, and P star USA is equal to 4. Okay, we can find the Q star USA. Can plug the price back into either the supply or the quantity, demand. We can plug it back into the demand function, and we get the price is equal to 32. Or price is equal to 4, quantity is equal to 32. Let's do the same for Mexico. Okay. Here is the Mexican supply and demand. Okay, we can put this 12 about the same spot. Make that 6 over here. Here's our demand curve. Our supply curve is going to be just a vertical line intersecting at 2. So this is Mexico. This is the USA. Let's find the equilibrium for Mexico. How do we do that? Same way we did in the United States. Set supply equal to demand. 6 minus 1/2 P equals 2. So that means 4 equals 1/2 P. The price in Mexico is equal to 8. Quantity in Mexico is equal to 2. So I apologize for my handwriting. I'm still getting used to drawing on this whiteboard. When I put my palm on the whiteboard, It makes it expand. I'm working this out. So I'm writing without touching my palm to the whiteboard, which makes it difficult. Okay, so when the markets are not integrated, in other words, there's no pipelines going between the markets, or between the U.S. and Canada. Sorry, the U.S. and Mexico. The price in the USA is $4 per trillion cubic feet of natural gas. I failed to mention that up here. The quantities are in the units. Q units are trillion cubic feet of natural gas. Prices are billions of dollars per trillion cubic feet per year. So these are per year. Trillion cubic feet per year. The price in Mexico is 8, and the quantity in Mexico is 2. Okay, what if we integrate the markets? What if we say there is a, so let's look at our slides here real quick. Here's where we are. Question 1. Suppose there are no natural gas pipelines between the U.S. and Mexico. Find the price and quantity of natural gas consumed in both countries. Question 2. Now suppose there's an unlimited pipeline capacity between the two countries so that the two natural gas markets are integrated. Find the price and quantity of natural gas consumed in both countries. What is the quantity and direction of natural gas flows through the pipeline between the two countries? All right. Now the markets are integrated. How do we find the aggregate demand supplied and aggregate demand and aggregate supply? Okay, well, Q2, let's do blue. Q2. The demand is the sum of the two curves. So Q demand total is equal to Q demand USA plus Q demand Mexico, which is equal to 40 minus 2P plus 6 minus 1/2 P. That's equal to 46 minus 5/2 P. Same thing for supply. Q supply total is equal to Q supply USA. Can't spell USA. Plus Q supply Mexico. That's equal to 8P plus 2. All right, now we can figure out what this market would look like if it were integrated. Let's draw it out. Okay, now the demand curve intersects at 46. That's our demand curve up here, 46 minus 5/2 P. It's going to have a P-intercept of 18.4. So our demand curve looks like this. It's going to start, the supply curve is then going to start at 2 and go upwards from there, like that. So here's demand, here's supply. The intersection is going to turn out to be 35.6. Prices are going to be 4.2. Let's solve for that. Okay. Just like in the non-integrated market, we're going to solve for the equilibrium by setting supply equal to demand. Supply equal to demand is going to be 8 P plus 2 equals 46 minus 5 halves P. That's going to give us 44 equals 21 halves P. That's going to make it so P star total is equal to 4.2. $4.2 billion per trillion cubic feet of natural gas. Q star total is equal to 35.6. Okay, prices in the two markets are equal because the market is integrated. But the quantities are unique. So the quantity in the US is going to be 40 minus 2 times 4.2, which is the price. Turns out that, oh boy, that's equal to 31.6. So the US is consuming 31.6, while Mexico is consuming 6 minus 1 half, 4.2 equals 3.9. What were they consuming before? Let's look. So prices before were, where are they? Prices before were $4 in the US and $8 in Mexico. 32 quantity consumed in the US was 32. Now the quantity consumed in the US is 31.6. Prices in the US have gone up a bit. So just like we said in the slides, if the US starts exporting natural gas onto the world oil market, then the price in the US is going to go up. So here in our example between the US and Mexico, the price is going to go up because the price in Mexico is higher. So consumers are going to be upset, but producers in the US are going to be excited. Consumers are going to consume a little less, prices are going to go up. In Mexico, Mexican consumers are going to be excited because now they're consuming 3.9 trillion cubic feet per year, whereas before they were consuming 2, and the prices have declined by 2. But actually more than 2, quite a bit. Prices have declined a lot. Okay, what's the next question? The next question is, in reality, there are several small pipelines between the US and Mexico, and the Mexican government is greatly expanding the pipeline capacity between the two countries. For example, the project Los Ramones will increase the capacity between the two countries to 1 trillion cubic feet per year. What will the effect of this infrastructure project what will be the effect of this infrastructure project on the price of natural gas and quantity of natural gas consumed in Mexico and the US? Okay, what does this do? This changes, in the previous example, we had unconstrained pipelines between the two countries. Now we have a pipeline that's constrained. The project would allow for 1 trillion cubic feet per year. If projects, we forgot to answer the second part of question number 2. Which direction is natural gas flowing when there's pipeline infrastructure between US and Mexico? Well, clearly it's flowing from the US to Mexico. How much is flowing from the US to Mexico? Well, the quantity in Mexico after the pipelines is 3.9. The quantity in Mexico before the pipelines is 2. So we have a difference of 1.9. So 1.9 trillion cubic feet without constraints are flowing from the US to Mexico. Wow, my handwriting gets really bad on this thing. Okay, so what if we implement a capacity constraint on our pipeline of 1 trillion cubic feet per year? That's going to be less than what Mexico would like to import from us. Well, we know that this is going to cause, relative to no no integration, this will cause prices to go down and quantities to go up. So let's figure out how can we, if we have a 1 unit constraint on the flow from US to Mexico, how can we figure this out? So what's this going to do to markets? Quantity demanded in the US is going to be 40 minus 2p USA. So this is what we had before, but now we're adding one because that's the demand from Mexico. So this is the demand on US producers. So this is Mexico. The quantity supplied in the US is going to be the same at 8p. The new equilibrium in the US is going to be solved by setting demand and supply equal. 40 minus 2p USA plus 1 equals 8p. All right, going to give us 41 equals 10p. So p star USA is equal to 4.1. The Q in the USA is going to be 40 minus 2 times 4.1. So now we're going to leave off that one that's going to Mexico for the quantity demanded in the US. So this is the quantity consumed by US consumers. That's going to be 31.8. We could add that one back in, but we're going to count it over in Mexico. So that would be double counting. All right. Now let's look at the quantity demanded in Mexico. All right. Quantity demanded in Mexico. It's going to be the same as it was before. 6 minus 1/2 p. The thing that changes here is now Mexican supply is equal to 3. It was 2 before, but we have 1 coming from the US. So additional 1 from US. We know that that pipeline is going to be full all the time because we know that the prices in Mexico are higher than they are in the US. And we know that oil or the natural gas is going to flow from the US to Mexico. And therefore, that pipeline is always going to be full with natural gas going from the US to Mexico. So what's the new equilibrium? New equilibrium for Mexico is going to be 6 minus 1/2 p equals 3. So then we have 3 equals 1/2 p. So p star Mexico is equal to 6. Q star Mexico is now equal to 6 minus 1/2. 6 minus 1/2. 6, which is equal to 3. Q total, we could figure this out. So this is the total between the US and Mexico is 31.8 plus 3, which is going to be 34.8. Okay, so what's happening here? With the constraint, the prices the prices in the US still go up, but they go up a little bit less than they did before. So here's what they were with unconstrained. I circled it in green here. With unconstrained pipelines between the US and Mexico, the prices were 4.2 because more natural gas was flowing to Mexico. With a constraint, the prices are 4.1. Without any integration, the prices were 4. So US consumers are not happy about this. In particular, they're consuming less than they were, 31.8. Mexico is happy. The price in Mexico goes down relative to the unintegrated market. Unintegrated Mexican prices were 8. The integrated Mexican prices without a constraint are 4.2, and with the constraint, the Mexican prices are 6, and then quantity consumed is 3. Down from when there is no infrastructure constraint of 1 trillion cubic feet. So that's how we would solve that. So what's the final question? The construction of pipelines across international borders requires approval from the U.S. government. Will natural gas producers in the U.S. be in favor of the pipeline construction? Will natural gas consumers in the U.S. be in favor? Well, we can tell that the producers are going to be in favor because they're going to receive higher prices. But the consumers will not be in favor because they're going to be paying higher prices and consuming less natural gas. So it depends on who you are. If you want to have an integrated market, who's it going to benefit? Is it going to benefit the producer? Yes. Is it going to benefit the consumer? No, unless you're in Mexico. All right, I'll leave it at that for now. I will post this and I will give you information on how to access it.